So section 6.5 is all about trapezoids, so our objective is to use the properties of trapezoids. Here's some vocabulary terms you need to know about trapezoids. We're actually going to talk about two different types of trapezoids, like the general everyman's trapezoid, and then we're going to talk about something called an isosceles trapezoid. So here's the first general definition. A trapezoid is a quadrilateral with exactly one pair of sides parallel. So unlike parallelograms where both sides are parallel, this one just has one pair. And we call the parallel sides the bases. Usually the bases are like this, sort of stacked on top of each other, but sometimes the bases go up and down. So you just have to be aware of that. But the bases are always marked as being parallel. And then the legs are just the other two. And then sometimes you'll see this guy right here, a segment drawn in the middle. That's called the mid-segment. The mid-segment connects the midpoints of the legs. And then here's a little formula for finding the length of the mid-segment. You're actually just taking the average of the bases. So you add the bases and you divide by 2. Or you could think about it as adding the bases and multiplying by 1/2. So go ahead and get those down, and then we'll look at those special types, the isosceles trapezoid, and then we have 8 examples for today. So here's some information about isosceles trapezoids. To be an isosceles trapezoid, the legs have to be congruent. When that happens, a few extra things, special form here. So we have the lower base angles are going to be congruent, the upper base angles are going to be congruent, and the diagonals are congruent if your legs are congruent. So lots of cool things happen in there. And then here's just a special note. When it's an isosceles trapezoid, either of the base angles, the lower base angles, is supplementary to either of the upper base angles. We didn't really talk about this with any old trapezoid, but it's actually true that the base angle, the lower base angle and the upper base angle are always supplementary on one side and on the other side, but when it's isosceles, you could sort of interchange them. So kind of a neat property there. But it is something we're going to use for all trapezoids, that the base angles are supplementary. Do you guys have any questions on any of the vocab, regular trapezoids or isosceles trapezoids? So the first 2 examples, you are supposed to just say whether it's a trapezoid, an isosceles trapezoid, or neither. So number 1, what do you think? Do we have a pair of sides that are parallel? Yeah, these 2 sides are parallel. Now you have to decide, are the legs congruent? Are the legs congruent? Yeah. If you have a pair of sides that are parallel and the legs congruent, that's when it's an isosceles trapezoid. Sort of like an isosceles triangle where 2 of the legs had to be congruent. Same thing here. Just 2 of the sides have to be congruent. All right, number 2, trapezoid, isosceles trapezoid, or neither?
You said trapezoid,
Trapezoid, isosceles trapezoid, or neither of those? Yeah, this is just a trapezoid. You can tell it's a trapezoid because of these arrows. That means that these sides are parallel. So it's definitely a trapezoid, but it can't be isosceles because these are not congruent. Okay, so you're looking for a pair of parallel sides. That means you're going to have a trapezoid. If the legs are the same, it's an isosceles trapezoid. If neither one of those is true, then you have to say neither. What are your questions? All right. Here's example 3 and example 4. We are supposed to find the missing angles. Now this is where that supplementary information comes into play. If you have a trapezoid, the base angles on one side are always supplementary, and the base angles on the other side are always supplementary. So one of your upper, one of your lower on the left of your trapezoid, one of the upper, one of the lower on the right side of your trapezoid are supplementary. Supplementary means they add to what? 180. So if I want to find angle E, I'm going to take 180, subtract the measure of angle H. What's angle H? 90. So that gives me 90 for E. Okay, I need to do the same thing to find F, except now I'm subtracting what from 180? 45, very good. Which is 135. Now, it's easy when you're given like the regular old trapezoid, where the bases, the two sides that are parallel, are on the top and the bottom. This one's a little different because they're on the sides. So anytime it's on the sides, just sort of, I always just imagine it rotated, like if you like came over here and you pushed it over and then it was laying down here. I always just picture it like that. I think it makes it easier just because it looks like the more traditional one. But if I want to find angle H, what do I have to subtract from 180? The 95, very good. Again, because those are on the same side of the trapezoid when you turn it right side up. Okay, you don't want to go on the same parallel line. You want to go on the one next to the other parallel line. It's kind of like these are the parallel lines, and then this is the transversal, and these are alternate interior angles, if that helps you remember. But what do you get when you subtract those? 85, good. Alright, and then how would I find the measure of F? 180 minus 122, good. Which is good. And you can also use the diagram, like the size of the angles as clues. F looks smaller than H. So if you get like that this was 58 and this was 85, you might want to rethink things. So you can use that as a hint as well. Any questions on these? All right, next we're going to look at isosceles trapezoids. So we know these are both isosceles trapezoids. They're trapezoids, first of all, because we have a set of parallel bases. And then we know they're isosceles because the legs are marked as being congruent. Now, one of the properties of isosceles trapezoids is that the upper base angles are the same and the lower base angles are the same. So if you know that B is 115, what's C going to be? 115. They're the same. Good. Now I'm going to give you a second to try to think of a way we can find A and D. Any ideas how we're going to find A and D? Yep, you do 180, subtract 115, and what does that give you? 65, good. So that gives us the measure of angle A, and then what's the measure of angle D? 65, they're always the same, good. So once you find one of them, you have the other one automatically. Good. Alright, I have angle C right here. It's 45 degrees. So which other one do I know right away? D. Very good. The lower base angles are the same. So this one's going to be 45. And then I know A and B are going to be the same, I just don't know what they are yet. Yeah, we're going to do 180, we're going to subtract 45, which gives us 135. So these are both going to be 135. Good. You guys have questions? We have 2 more examples left, and then it'll be homework time. Everybody good with these? Alright, here's the last 2. We are finding the length of the mid-segment. The length of the mid-segment. Now, we wrote down earlier the formula for finding the length of the mid-segment. If you cannot remember it, it's 1/2 base 1, that just means one of your bases, plus base 2, that just means your other base. It does not really matter which base you use for either one. They're interchangeable because we're adding them. I usually use the bottom base as base 1, and then this is base 2, but really it doesn't matter. Essentially what you're doing here is you're finding the average of the 2 bases. So we're going to add the bases together. So the bases here are 10 and 5. When you add those together, you get 15. And then you're multiplying by 1/2, which is the same thing as dividing by 2. That's how you find an average, right? Of 2 numbers, you add them together, divide by 2. Same thing here. You want to add the bases together, and then you want to divide by 2, or you can think about it as multiplying by 1/2. Does anyone know what 1/2 times 15 gives us? It's an odd number, so I'm expecting a decimal answer. Anybody know? Very good. 7.5 or 7.5. Either way you want to write it is fine with me. So again, we just found the average of these 2 numbers. That gives us the length of this guy. Alright, same thing on number 8. I need to find the average of the 2 bases, which is 1/2 times the sum of the bases. When I add this together, what do I get? 30. And what's half of 30? Or 30 divided by 2? 15. Good. Again, you might be able to do it just by looking at it, like what number is in between, like halfway between these two. 15. Some people can just look at it and figure out what the average is. That is everything you need to know about trapezoids. What are your questions? Alright, I'm going to give you a worksheet. We don't need to do any of them together. They're pretty straightforward. They match right along with the notes. So you have the rest of the class to work on those, and then they are due when I see you tomorrow.